Now, let us understand principal component analysis. So, principal component analysis is one of variable reduction procedures. It is so much useful when we have a data with so many variables and we believe that there is some redundancy in those variables. So, because of redundancy, we believe that it should be possible to reduce these observed variables into smaller number of principal components. So these principal components are just artificial variables. However, we want those principal components to account for most of the variance in the observed variables. So, how are the number of components extracted? So, what we should understand about principal component analysis is that the number of components that are extracted during principal component analysis, they are equal to the number of observed variables that we are analyzing. So we only keep few components that account for meaningful amount of variance. So only these very first few components, we retain them, we interpret them, and we use them for subsequent analysis, such as in regression analysis. Let us understand these components. So the first component that we extract during PCA is account for maximal amount of total variance in the observed variables. Now, we look into the second component. This second component will account for maximal amount of variance in the data set that was not accounted for by the first component. However, it should be noted that this second component is uncorrelated with the first component. So, the remaining components that are extracted in the analysis, they have these two characteristics that each component will account for maximal amount of variance in the observed variables. However, this was not accounted for by the preceding component and it will be uncorrelated with all the preceding components. So, a PCA proceeds in this fashion. With each new component, it accounts for progressively smaller and smaller amount of variance. So we don't have to interpret those or we don't have to retain them. So we only pick the very first few components. Now, when it comes to the solutions that you will get in principal component analysis, we have orthogonal versus oblique solutions. So an orthogonal solution, this is the one in which the components, they remain uncorrelated. As the name says, orthogonal, which means uncorrelated. It is possible to perform a principal component analysis that results in correlated components. And in that case, we will have an oblique solution. Now, let us understand the steps in conducting PCA. So, the initial extraction of the components. So, in principal component analysis, we use eigenvalues. The eigenvalues, they represent the amount of variance that is accounted for by a given component. Okay? Then secondly, we want to determine the number of meaningful components to retain. So we have certain techniques that we can use. The first one is eigenvalue 1 criterion. So with eigenvalue 1 criterion, we retain and interpret any component with an eigenvalue that is greater than 1. Next, we can use a scree plot. So when it comes to using a scree plot, the components that appear before the break, so we assume that those components are the most meaningful and we shall retain them. Okay? But those that appear after the break, they are assumed to be unimportant and we don't retain those. And there's actually no need to interpret them. We can also, as we will see, is that we can also visualize when it comes to proportion of variance accounted for. So where we are retain a component if it accounts for a specified proportion of variance in the data set. And that is the formula to calculate this proportion of variance that is accounted for by a given component.